All right, so now that we've had some practice adding and subtracting decimals, we are going to look at some word problems that involve both adding and subtracting decimals in today's lesson. So what I want you to do is open up to page 180 in your textbook. You'll see that there's this guided practice section up halfway down the page. We're going to look at problem number 4 underneath that guided practice section here. So when we are looking at word problems, the biggest thing you have to think about or kind of figure out as you're reading, are we adding or are we subtracting? Okay, because once you figure that out, you know how to add or subtract, or add and subtract decimals. So you just have to figure out which operation are you using, add or subtract, and then you can solve the problem. Okay, another big thing to think about when you are working with word problems is your answer should always have a label involved with it. Okay, so as you're reading the problem originally, you can kind of think about, all right, what is my answer going to have as its label, or what am I trying to find out? What information am I missing, or what information am I trying to find out from my label? All right, let's look at number 4. Grayson is making a snack mix for his family camping trip. He added 14.52 ounces of peanuts to 27.35 ounces of granola. How many ounces of snack mix does he have? I saw a keyword in this problem that actually flat out told me what operation I'm going to be using to solve this problem, and that was the word added. So now I know I need to add these two decimals together. Okay, so let's try it. 14.52, and remember with adding you have to line up your decimals. So I'm going to put 27, zoom in a little here so you can see. I'm going to put 27.35 right underneath it, and then I'm going to add. So 2 plus 5 is 7. 5 plus 3 is 8. Bring down my decimal point. 4 plus 7 is 11. Carry the 1. 1 plus 1 plus 2 gives me 4. So now my answer, my number answer is 41.87. But my label attached to that, because every word problem needs a label at the end, is ounces. Okay, because it says how many ounces. So as you're reading through the problem, it might help you to underline those keywords that you find that are telling you what operation to be using, as well as the label that you're looking at. That way, once you figure out the problem, you can quickly go back and look at your underlined words and go, all right, yep, I underlined that. That's my label. Write it down here. And then I would box my answer when I'm done. All right, now I want you to flip to page 183, which is a couple pages away there. And we're going to look at problem number 23. So problem number 23 involves money. You'll probably find a lot of money involved in these decimal operation word problems, just because decimals are heavily involved with money. All right, so number 23 says the current balance of Tammy's checking account is $237.80. So I'll give you a little bit of backtrack here. So balance just means how much money is left, okay? How much is left, just in case you didn't know that. A lot of you probably don't have checking accounts yet, so you may not know what that means. So the current balance, or how much is left in Tammy's checking account, is $237.80. Find the new balance after Tammy writes a check for $29.95. So if her balance is this, and she's writing a check, you have to think about, is she adding money to her balance, or is she subtracting money from her balance? If she's writing a check, that means she is paying someone for something. So that means that she is going to have less money in her account, or she's going to be subtracting $29.95 from $237.80. So let's set that up and solve it. So because this is money, I'm going to carry down my dollar sign in the solving of the problem. $237.80 minus, now I have to line up that decimal point, so I know my 9s are going to go under my 7 and my 8. And we'll set it up that way. All right, so looks like we're going to have to do some borrowing here. 0 minus 5 is, can't do it. 8 minus 9, can't do it. 7 minus 9, can't do it. 3 minus 2, we can do that. Let's do it. Take the 10 away from there, that becomes a 2. Bring that 10 over here, becomes 17. Need to continue, so this will become 16. Bring that 10 over here, that becomes 18. Cross that out, that becomes 17, and we now have 10 at the end. So now we can do our subtracting. 10 minus 5 is 5. 17 minus 5, or 9, is 8. Bring down my decimal point. 16 minus 9 is 7. 2 minus 2 is 0. And 2 minus 0 is 2. Bring down my, oops, I didn't put my dollar sign there. Bring down my dollar sign, and my answer is $207.85. And now, because money is our label in this one, we don't need to write a word after our digits or in our answer because this is our label. Now let's just think if this makes sense. So we start with $237.80. That's pretty close to $230 or $235, okay? So if we kind of round this up or estimate this, and we estimate this number was awfully close to $30. So let's just take a look. If we roughly have $230 here, I'll write it over here, and we subtract $30 from it, we should have around $200 left, okay? And let's double check that with our answer. I'd say $207.85 is pretty darn close to $200. So I know that my answer is probably going to be correct unless I added wrong or subtracted wrong, which is an easy fix. But we know that our decimal point is in the right spot then. Okay, now let's look at number 24. Number 24, the annual rainfall for Caiston Falls was 50.38 inches in 2012. In 2013, the annual rainfall was 55.76 inches. What is the difference? So that's one of my keywords here in rainfall between the 2 years. And I know my other keyword is going to be inches. That's probably going to be my label since that's the measurement that we're using in this problem. So difference, if you see that word, that's probably going to tell you that's a subtraction problem, okay? So the difference between the 2 years, which means you're going to take the second year, that's going to be the number on top, 55.76, and you're going to find the difference between that and the year before, which is 50.38. Okay, now let's subtract. So we can't do 6 minus 8, but we can do 7 minus 3. So let's borrow from here. This becomes a 6. Bring that 10 over here. We're left with 16 minus 8 gives us 8. 6 minus 3 gives us 3. Bring down my decimal point. 5 minus 0 is 5. 5 minus 5 is 0. And because that's a 0, I don't have to write that in my answer. All right, so now we're left with 5.38, and then our label would be inches. We'll box that. But now let's just do our estimating to double check and see if our decimal point's in the right spot. So I know that this is close to 55. Okay, so 55 minus, and then this other digit is close to 50. So I know my answer should be around 5. And it looks like our answer is around 5. It's not 0.538, it's not 53.58. Our answer is right around 5, so it should be correct. And our decimal point's in the right spot. Okay, let's look at problem number 25, the STEM problem right below it here. All right, so it says the melting point of sodium is 97.8 degrees Celsius. The melting point of potassium is 63.65 degrees Celsius. How much higher is the melting point of sodium? So I see two things here. I see my label, which is going to be degrees, and I see how much higher is the melting point of sodium. Okay, so a couple things here. Because that's not necessarily saying the word added or subtracted like we had in the first problem we worked on the first page, in page 181 or 180. We have to kind of figure out what this means. So how much higher is sodium, which is this one here, than potassium? So I'm going to have you pause this video. You're going to solve it on your own. When you are done solving it with the work shown, your label written in, and you have double checked to see that your decimal point is in the right spot, you're going to continue this video and watch my answers come up on the screen. All right, so how much higher is going to mean that we have to subtract something from something. So we're going to take this, because this is the higher number, and we're going to subtract 63.65 from that number. So let's line up our decimal points. 97.8 minus 6536. 63.65. I'm going to have to fill in my 0 here, and let's subtract. So I see that I can't do 0 minus 5, so I'm going to have to borrow from here. That becomes a 7, and this becomes a 10. 10 minus 5 gives me 5. 7 minus 6 is 1. Bring down my decimal point. 7 minus 3 is 4, and 9 minus 6 is 3. So we know that sodium is 34.15 degrees higher than potassium. Okay, but let's double check and make sure that our decimal point's in the right spot. So roughly, this is pretty close to 100, and this is pretty close to 60. Okay, now 97, if we do 100 minus 60, we're left with 40. And I know that 34 and 40 kind of seem like they're a little far away from each other, but they're really not, because if you were to put your decimal point here, you would have gotten 3.415. And I know that 3 and 40 are a lot farther apart from each other than 34 and 40. So I know my answer is roughly around 40, and 34.15 is that. So my decimal point's in the right spot. Now, you may have had an error subtracting or adding throughout here, and that's a simple fix. We just really want to make sure that our decimal point's in the right spot, because that can really make or break an answer to a problem. Okay, your homework is going to be listed on the assignment in Google Classroom for this. You have problems 7 through 10 on page 181, as well as page 182, number 11. Okay, I will write them in there for you. Make sure that you have those done with you when you come to class, and good luck. Let me know if you have any questions.